All right, so today we've got, actually next couple classes are going to be a little bit easier. We're well ahead on schedule, so a couple quick announcements. So we are on track for our first quiz day. So basically what that means is next Tuesday, we're not going to be meeting in class. You're just going to take the day to finish up working on all your assignments, get all those submitted. Right, and on Tuesday you have your units 1 and 2 homework and quiz. So that's 4 turn-ins total that are due next Tuesday. So we're not going to be meeting. Just spend the extra time to finish up your assignments. And again, for those assignments, it's open notes, open book. You can search up answers, use Excel. The only thing that I fail students for is working with other students. On homework, I don't really care. Quizzes, and especially your exam, I do pay close attention if there's signs of students working together. So don't work with anybody else, but it's open notes and free resource otherwise.
So next Tuesday, we don't have to come to class.
Yeah, and I'll send out an email reminder to everyone that we're not meeting on Tuesday. Yeah, so I don't know about the rest of the month, but at least next Tuesday, you don't have to meet here for this course. Any questions about your homework or quizzes while we're on that topic?
I got a couple of questions at the end of the class. If there's
Yeah, sure, yeah. After the planned lecture, I guess we can go through any particular questions that you have on that. That works too. So a couple announcements. I don't think I mentioned this last class, but there's a teaching in Japan opportunity that's available. That's, I think, more geared toward after graduation. So if you're close to graduation, save the link for this. This is usually an annually reoccurring event. I wish that I had done something like this right after I had finished school, because great opportunity to travel and learn about another country. So if you're interested in that, definitely recommend checking that out. You've probably seen flyers around school. It's Constitution Day, so previous Vice President Pence, today, he's going to be here this afternoon after class. If you're interested in that, over at Tucker Theater. Someone had emailed me about if that's extra credit. It's not. There will be extra credit opportunities available in this class, and I'll email you all about that when they become available, probably about a month from now. There are also some Ignite events starting this afternoon, right? Elevator pitches and getting ready for the career day. So if you're interested, these are available this afternoon and tomorrow afternoon. I forgot to post info on this for this course page. But our department is looking for economics or finance majors that are interested in joining the homecoming parade on Saturday. So if you're an economics or finance major interested in that, shoot me an email and I'll connect you with the department chair. You'll get, I think it's a free department shirt, and we'll be handing out candy, so you'll be able to eat whatever candy that we're giving out. I'll post some info on that on this page as well. All right, so today we're going to talk a little bit more about interest rates, and that's going to be our focus. In next class, we'll wrap up the first 2 units with discussing more about loan payments. All right. So far, we're dealing with time value, which is how much is something worth today, right? Taking future cash flows, discounting those future cash flows back to today. We're estimating what the future value of something is. So saving up cash flows over the course of a career, what's that going to be worth sometime around retirement? And right now we've been using just annual compounding. That's been the basic assumption, and very often that's the go-to assumption when we're dealing with time value, is that we're using annually compounding interest rates. But in actuality, a lot of investments compound more frequently, sometimes much more frequently. And as we increase the amount of compounding, in other words, rather than compounding once per year, compounding on, say, twice per year, semi-annually, or quarterly compounding, monthly compounding is common for things like credit cards. And then we have things like daily compounding, which is more frequent for something like the stock market. I believe student loan payments are usually compounded on a shorter time interval. And as we increase the compounding frequency, that can increase the value of investments, and it can increase the cost of loans that we're holding on to. Right? So the more times per year that an asset is going to be compounding, the more valuable it is to us. And conversely, the more frequently per year debt that we're holding on to compounds, the more costly it's going to be for us. All right, and this becomes much more clear when we're looking at longer term and larger investments. Right? So if you're just looking at a $100 balance, the marginal difference of compounding on a weekly basis relative to an annual basis will be pretty small, right? We're going to be talking about a couple of cents. But as we scale that value up, as with all time value problems, you're going to see a significantly greater difference in the value of an asset based on its compounding frequency only. Thankfully, it's a really simple adjustment when we're going from annual compounding to these more frequent compounding periods. All right, so the basic way that we adjust our time value money formulas or functions that we've been using is we adjust by the number of compounding periods, which we'll be using M to reflect the number of compounding periods. All right, so there's three things that we're going to have to make an adjustment to: the discount rate, the number of periods, and and if there is a payment, the payment's taking place. All right, so specifically what we do is we divide the discount rate by the number of compounding periods per year. We multiply the number of periods times the number of compounding periods per year. And if there's a payment, we divide that payment by the number of compounding periods per year. All right, so what this is saying is that, let's say that we're going from annual compounding to semi-annual compounding, which is every 6 months. Right, so 2 compounding periods per year. So if we have a 10% discount rate, what that means is we're getting 5% in the first 6 months, and then compounding on top of that 5% for the last 6 months. Right, so in other words, we have 5% in the first 6 months. Number of periods is 2. Right, so we have 2 compounding periods per year, semi-annually. Similar with the payment, right? If we're dealing with, say, a $100 coupon, rather than receiving that $100 at the end of the year, we're getting $50 halfway through, and then another $50 in the second 6-month period. So the most frequently, or the most common compounding types that we're going to see is annual, which is the default assumption when we're looking at time value. We also have semi-annual, which is occurring 2 compounding periods per year. Quarterly, or 4 compounding periods per year. Monthly, so M is going to be equal to 12, 1 for each month. And lastly, daily. So with daily, historically, since before Excel basically, we would use 360 days to compound rather than 365, just because that rounder number made it easier to make these calculations, which saved a lot of time when people were having to make these calculations either in their head or with older mechanical calculators. All right, so very often in finance, we'll be using 360 days rather than 365 days per year, just because of convenience. It's frustrating that this is still a trend when we have readily accessible, when we have computers that are readily accessible. So it's just one of those things that takes a long time to change. All right, so let's pop over into Excel and start working on some examples. All right, so the basic question that we're starting with here is, what's the value of a $1,000 investment earning 10% per year at the end of 1 year? All right. So we'll start off with the basic way of solving this, right? So we're going to use the formula and the function, just again, getting some practice in here. All right, so if we're using annually compounding, it's going to be, what are we doing? $1,000 times 1 plus our compounding rate of 10%. I'll just go ahead and type that in. Plus 10% raised to the number of years, right? 1. Or you don't have to do that additional step. That's just for the sake of what we're going to be working on here. All right. So 10% of $1,000, $100. At the end of the year, we'll have $1,100. All right, we should get the same answer using the function. It'll be the 10%, 1 year. This is a one-time cash flow, right? So it's not a reoccurring cash flow, meaning it's not a payment. right, and we got the same answer. So can you remind me, how many compounding periods per year are semi-annual?
2,
Quarterly?
4,
And monthly.
12.
Yeah. All right. So we're going to use this now to reference our additional compounding. Right? So again, the more we compound per year, the higher the value of an asset is going to be. So, right, we're not changing how much money we've saved up. We're not changing up our rate of return on our investment. The only thing that's going to be changing here is the frequency we're compounding within a year. All right, so I'm just going to go ahead and copy and paste these formulas down, and we'll adjust them as we need right now. All right, so again, right, just I got a reminder built in here on what we're doing. So we're taking our annual information and turning them into semi-annual, quarterly, or monthly equivalents. All right, so in the semi-annual problem, basically what we're saying is we're earning 5% the first 6 months, and then we're earning another 5% on that already compounded 5% in the second 6 months. And so that's why we're getting this additional value out of the more frequent compounding periods. All right, so the adjustment we're going to have to make here so it's going to be the 1 plus 10%. I swear this computer screen is smaller than what you're seeing on this screen, even if you're sitting at the back of the room. It's going to be the 10% divided by the number of periods, 2. And then the number of years that we're dealing with, in this case 1 times the number of compounding periods. Oh, something went wrong. Yeah, parenthesis went to the wrong place. There we go. All right, so just by going from annual to semi-annual, we're adding just a couple additional dollars in savings. All right, and we can do the same thing here. We've got the rate divided by 2, and the number of periods multiplied by 2. All right, and again, the reason we're making this adjustment now is we're getting 5% in 6-month increments, and we're going from 1 single year to 2 semi-annual periods. All right, so that's the motivation for making these adjustments is, again, going from that 1 compounding period per year to the semi-annual compounding period. All right, and again, when we have our information regularly referenced, we can start copying and pasting our formulas to update that information. So we're going to go from the semi-annual compounding to quarterly compounding. And again, what should happen to these values as we increase our compounding frequency? Should increase, yeah. Oh, what did I misreference here? Oh, see, I messed up and I divided by 2 rather than referencing the cell, and that's part of the reason why references work better than putting nominal values in, because we can now adjust it. There we go. So I updated that. So again, yeah, we added a little bit of value. And again, going from quarterly to monthly, we're seeing a little bit more value still. All right, so in this first example, it's not much, right? It's a couple dollars difference. A couple dollars doesn't really mean all that much, right? But let's scale this up a little bit. Let's say that now we're saving up, let's say $20,000 per year, earning an average rate of return of 8.5% per year, and we'll retire in 45 years, right? So this is a long time period. It's a lot of money we're saving up. But as we scale up these differences, we're going to see a significantly greater difference in the nominal value of our retirement portfolio just because we're saving up a little bit more frequently. Actually, yes.
So you divided to find the semi-annually, the quarterly, and the monthly, you divided your rate by your period, which is 2 in the semi-annually. Mm-hmm. Then you did that to the power of 1 of the... What was that again that you did? The power of what?
Yeah. So in the exponent here, it's 1 times the number of compounding periods.
Oh, that's okay.
Yeah. So again, what's going on here is we're getting this 10% instead of at the end of the year. We're getting 5% in the first 6 months, and then another 5%. So All right, so if we have our year, and we're earning 10% over this whole year, what's going on now when we have, right, we're going from annual, semi-annual. We still have this single year, but we're getting 5% in the first 6 months and another 5% in the next 6 months. All right, so this is still a year, but now this 1 year time period is being broken up into 2 semi-annual sections. So we're getting 5% in the first 6 months, and again, right, we're compounding an additional 5% on that 5%.
So pretty much we're just dividing our rate by the number of periods within the year.
Yes. And multiplying the number of periods.
The periods.
Yes. And there's a similar adjustment that we're going to have to make to savings. So I made one slight change here just to make it a little more intuitive. So we're saving up $12,000 per year. So on a monthly basis, how much are we saving up? $1,000 a month. Yeah. Right? So we're saving up $1,000 a month. It's still $12,000 over the entire year. There's 12 months per year, right? But now we're just saving up $12,000 each month, for example, when you get a paycheck at the end of the month. All right. So now we're going to see that as we scale up this information with larger amounts of money over longer time periods, we're going to see a significant difference in how much we can save just by increasing our compounding frequency a little bit. All right, so let's use the future value. I'll go ahead. Annual compounding, semi-annual, quarterly, monthly. So we're going to use the future value. So our rate is going to be 8.5%. That won't be changing. And that's going to be divided by the number of compounding periods. Then we'll have the number of periods, which is going to be 45 years, times the number of compounding periods per year. Now we have a payment, right? Now we have a reoccurring cash flow, and that's going to be $12,000 divided by the number of compounding periods. So just as an aside here, right? So we'll do the future value, 8.5% over 45 years with 12. Right? We're getting the same exact answer without making any adjustments, right? Again, what's going to happen here is we're going to start seeing this future value change as we increase the number of compounding periods per year. All right, so we're going to just copy and paste down this future value function as we go from annual to semi-annual. How much did our portfolio value increase? Let me put that a little bit out of the way.
Can you do the Excel function again for annual compounding?
Sure. All right, so we're doing the future value function equals FV open parenthesis. We have an 8.5% compounding rate, so 8.5%. Actually, I'm gonna do this a slightly better way, just so you can see the references a little easier. Rate, savings. We're saving up $12,000 per year over 45 years. All right, so now we can see that information a little better. That's going to be a cleaner way to reflect it. So we've got an 8.5% discount rate. Right, and remember our adjustments that we're making here. It's going to be our discount rate divided by M. So the 8.5% divided by the number of compounding periods. Now we're getting how many compounding periods we're dealing with. So we've got 45 years times the number of compounding periods. Last bit of information we're going to need to adjust and include how much we're saving. So $12,000 per year divided by the number of compounding periods. All right, I'm going to fix reference to this information that's not changing. Right? We're not changing how much we're earning every year. We're not changing how much we're saving up. We're not changing our savings time frame. The only thing that's changing is how many times per year are we compounding these savings. So just going to copy and paste down this annual compounding of value. So as we go from annual compounding to semi-annual compounding, how much larger is our portfolio value? Zoom in a little bit in case you can't see it. Annual compounding, semi-annual compounding. We're going from 5.4 million to 5.8 million. In other words, we're adding about $400,000 in portfolio value just from compounding a little bit more frequently. Again, we're not saving up more money. We're not earning a higher average return. We're not even saving up over a longer time period. The only difference is we're getting an additional compounding period per year. One additional compounding period per year is adding up to an additional $400,000 in savings over 45 years. And so this is really where we see the difference in compounding is compounded across time. Right? Over a 45-year period, we're saving up $1,000 a month, earning 8.5% rate of return on average. We're adding $400,000 in portfolio value just from compounding a little bit more frequently. And we're going to see this trend continue as we go from semi-annual compounding to quarterly compounding. Again, we're adding another $200,000 in portfolio value. We're not saving up more. We're not saving up longer. We're not getting a higher rate of return. We're just getting that compounding a little bit more frequently. And as we go from the quarterly to the monthly, again, we're adding a couple $100,000 more in value. All right, so from going from annual compounding to monthly compounding, we're getting almost $800,000 additional dollars in portfolio value just from getting those rates of returns a little bit more frequently per year. So that's from an asset standpoint. On the flip side of this is if you're taking out a loan and that loan is compounding more frequently per year. Any questions on the multiple compounding periods?
So I'm putting the formula in Excel. So my rate, which is 8.5, that stays the same, right? And then for my NPR, it's going to be like, it's 45 divided by 2. Is that correct?
So when we're making the compounding period adjustments, the three things that are going to be changing, here I outline it here, the payment, the discount rate, the number of periods are all going to have to be adjusted. All right? So what exactly you have to do depends what you're looking at. The payment and the discount rate, you have to divide by the number of compounding periods per year.
The payment and the discount rate?
Yeah. So when we're looking at semi-annual compounding, we're dividing the payment by 2, and we're dividing the discount rate by 2, or compounding rate by 2. And with the number of periods, we're multiplying it by the number of compounding periods, right? So again, looking at the timeline, as we go from annual to semi-annual, we're going from one single period over the whole year to semi-annual, which has 2 periods per year, right? In other words, we have one 5% period and another 5% period. So that's why we're doubling the number of periods and having the discount rate. Any other questions? Okay. All right, so when you're looking at a loan, the loan is required by law to state some information about the interest rate that you're going to be charged. Typically, you're going to be shown the stated and or quoted interest rate, which is basically the interest rate that you're shown on a loan. Typically, it's the interest rate that you're going to be charged within each period. Okay? So in other words, if you're going to be charged 1.5% per month, that's what the loan will reflect. Unfortunately, when you're looking at the cost of a loan, you have to be very careful in the information that you're provided and also in translating that information into the true interest that you are going to be charged. right? So very often quotes might be reflected in a way that don't reflect their true costs to you as a borrower, right? And typically lenders are going to be quoting the lowest interest rate that they are legally allowed to quote you at, which happens to be the stated interest rate in many cases. Right, so it's important to understand that the rate that you're going to be quoted is not necessarily the rate that you are going to be paying on a loan, which typically means you're going to actually be paying significantly higher interest than you're being quoted on a loan. So the annual percentage rate is very often the rate that you are going to see on a lot of loans. Right? And this is defined as the periodic interest rate multiplied by the number of periods per year. Right? And what this ignores is the fact that there's compounding within the year if there are multiple periods. Right? So if you're not being charged, say, 12% per year for your loan, if it's not a single compounding period, that means that there's going to be more frequent compounding periods within the year, and you're going to have to make that adjustment because this is compounding occurring within the year. All right, so in other words, the APR is showing us the simple interest rate, which, as we know at this point, right, we deal with compounded interest in actuality. Right? The rate that you are actually going to be paying on a loan isn't the simple interest, it's the compounded interest that you're going to be charged. So we're going to have to make an adjustment to the APR, which you are going to be quoted. We're going to have to estimate what's called the effective annual rate, or the EAR. Right? Thankfully, it's a relatively easy calculation. It's 1 plus the periodic rate that we're quoted, raised to the number of compounding periods minus 1. We're going to see that the effective annual rate is at least as high as the annual percentage rate, and the only time it's equal to the annual percentage rate is if you're dealing with annual compounding, which as a borrower is almost never going to be the case. Typically, you're going to be charged something much more frequently. So, for example, a lot of credit cards will be compounding daily. A lot of student loans compound at the daily level. So the APR that we're being shown on these loans is significantly lower than the effective annual rate. So we're going to do a couple examples here to start seeing the real difference now between these two rates. All right, so let's say that you have a credit card that's going to be charging you 1.5% per month. What's the annual interest rate on this card? The APR, what they're going to be required to show you, is 1.5% times number of compounding periods per year. All right, so in this case, 18%. I think a lot of credit cards are stating around 27 to 32% right now, something around there. So this is actually a bit low. Let's change this into the effective annual rate, which is going to be 1 plus our periodic rate of 1.5%, raised to the number of compounding periods per year, 12, minus 1. So we're adding an additional 1.5% interest just by including the compounding frequency. Now let's scale this up a little bit further. Let's say that we're looking at a 2% rate. All right, so it's going to be our 2% times the number of compounding periods. So 24% APR that you are going to be told is the interest rate you're going to be charged on this credit card. All right, so do you think the effective annual rate is going to be greater than, equal to, or less than the APR we just calculated? Greater, yeah. Again, the EAR is almost always greater than the APR. So we got 1 plus our 2% raised to the number of compounding periods, 12, minus 1. All right. So in the first example, we had about a 1.5 percentage point difference. In the second example, we have just under 3 percentage points difference between the APR that you were quoted and the effective interest rate that you're actually going to be charged. Right, one thing I do want to point out, credit cards have a very high interest that you are going to be charged. Right? The average cost of holding on to credit card debt is basically greater than any rate of return that you can get for having that debt. Right? So credit cards in and of themselves are not bad. It's good to develop your credit score. If you develop a good credit score, you can very often get really good credit card offers. The danger with credit cards comes from holding on to a balance month to month. Right, so in other words, if you have a credit card, it's really important that you're paying down your balance in full every month, because if not, you're going to be charged the interest rate of that credit card. And if you're charging interest rate on that credit card, it's going to compound significantly over the course of a year. So very important when you start dealing with credit. Credit cards can be a great way to build credit, a great way to have benefits from the credit card itself, but you need to be paying down the balance in full every month. Otherwise, you're going to be charged a lot of interest on that credit card balance. Any questions so far on calculating the APR or the year? All right. Let's say that you borrow $400 today and agree to pay back $465 in 2 weeks. What is the interest rate on this loan? All right, so the way we can do this is through the rate function. So the number of periods, we can calculate this. It's going to be 52 divided by 2, right? So basically we're just translating this 2-week period into an annualized basis, right? We've got a present value of $400 and a future value of $465. So we have an effective rate of 0.5%. Now keep in mind, over what time period is this 0.5% being charged? 2 weeks. Yeah. So 0.5% doesn't sound like much. But let's see how much this compounds to over the course of a year. Times, I don't remember how many, 52, what is that, 26? Yeah. 0.5% in 2 weeks translates to 15 percentage point APR. That's a little bit higher, right? 15 percentage point loan, that's higher than the average rate of return on the U.S. equity market, which is the typical higher end rate that retail investors are going to earn on their portfolio. So in other words, the cost of borrowing this money is likely greater than any benefit you can get from a return on investment available to you. But there's one additional step. We have to look at the actual charge that we're being made here, right? The APR is the simple stated interest. It's not the compounded interest that we're actually paying out. Right, so to get the year, we take 1 plus our periodic rate of 0.5% per 2 weeks, raise that to 26. So again, the year is higher than the APR, 16.25% per year that we're charged on this loan. Any questions so far? Yes.
What would be like the last three?
The last what?
The last. 244.
This one?
Yes.
Yes. Yeah, so we're using the rate function here. Right, so the number of periods is going to be 52 because there's 52 weeks per year, and this question is based on a bi-weekly basis. So we'll divide that by the number of weeks we're dealing with, in this case 2. So that's going to be the number of periods. There is no payment. It's just a present and a future value. So we're going to skip the payment. Our present value is going to be the amount that we borrowed, $400. And the future value is going to be what we're paying back, $465. That's how we get the 0.5%.
250.
I'm sorry?
250.
Oh, gotcha. Right, so the APR is the periodic rate. So in this case, the 0.5% every 2 weeks times the number of 2-week periods per year. So that's going to be the 0.5% times the number of bi-weekly periods we have per year, which is 26. So that's how we got the 15%. Just to refresh the ear, that's going to be our initial 0.5%, or sorry, 1 plus that 0.5%, raised to the number of biweekly periods, 26, minus 1. Any other questions? So we're going to be increasing the rate a little bit here now. So let's say that we borrow $400 and agree to pay back $500 in 1 week. All right, so we have a shorter time frame that we're paying the money back in, and we're paying a little bit more in interest right away. What's the rate on this loan? Can anyone remind me how we're going to be calculating the rate?
Equals rate using the Excel function.
Yeah.
Okay, rate. And then you got your, and it said NPR the first, which is weeks, so it's 52.
Exactly. 52 weeks per year. This is a 1 week time period, 52 weeks per year. That's going to be our number of periods. Yep.
Comma, PMT, comma, or 0. Then present value, negative 400. And future value is going to be 500.
Yes, exactly. Oh, not 5,000, 500. Remember, right, we're dealing with a time value function, so we need a negative sign on the present values or the future values. Right? One or the other, make sure your signs are matching up. So, we got a rate of 0.43%. Aren't we expecting a higher rate? Why do we have a lower rate than the previous example we just did?
Like 500 back each week.
Or is it because you're paying it like in short time periods, instead 1 week instead of 2?
Exactly. Right? That's the difference between these two examples. We're looking at a weekly rate of 0.43% relative to a twice week?
Bi-weekly.
Bi-weekly, I was correct in saying that? Okay. Relative to a bi-weekly rate of 0.58%. All right, now let's see what this translates to in an annual term. All right, so to get the annual rate, we take the periodic interest rate, multiply it by the number of compounding periods per year. Can anyone remind me how many compounding periods are we dealing with? 52. All right, so we have an APR of 22.36%. All right, and again, what do we think the year is going to be relative to the APR? It's going to be higher, yeah. 1 plus our periodic rate raised to 52 weeks per year minus 1. 25% effective annual rate that we're being charged on this loan. Any questions on calculating rates, APRs, or years? All right, so one thing that I do feel is really important to point out are payday loans or a cash advance. Right? Basically, this is just a small, short-term, unsecured loan that's going to be paid. Very often, right, at the way it'll work is you write a check to the lender that's dated sometime a week or two in the future that you're going to be paying back. On that day, you can bring in cash repayment, or the lender's going to cash the check. If the check doesn't clear, then the loan automatically renews and you're going to be charged interest. Right, so borrow $400 today, agree to pay back $465 in 2 weeks. What's the interest on this loan? That's what we were, oh, did I mess up the rate? I think I messed something up in this calculation. What did I do?
So we did it by weeks.
Yeah. I may have flipped it like should be. I wouldn't have thought it would lead to that big of a difference. Oh, I think I realized what I did wrong. So there we go. That's okay. So I messed up in calculating the rate initially. So it should have been just left as a single, just as a 1, basically because that 2-week chunk is the single time period the compounding interest is occurring over. So I messed up the rate calculation. I'm sorry about that. So again, what I did wrong, it should have been just a 1 under the number of periods because we've broken this up into a 2-week. What is correctly occurring, right, the number of compounding periods is still the 52 divided by 2.
So it's 1 because we just pay it back that one time?
Correct.
Okay.
That one, or I should say that 1 period.
That 1 period.
Yes. Yeah, so that's where I screwed up. All right. This makes more sense with the discussion that I wanted to end up with. There will be some differences from the PowerPoint since I'm rounding to weeks rather than using days, but that's okay. That still ends up with roughly what I wanted to show. All right, so the discussion that I wanted to have that I intended to and totally messed up with my miscalculation, right, we're dealing with actually a much higher interest rate than I initially put forward. Right, so on a single period basis, you're getting a 16% interest rate that's charged over that time period. Scaled to the year, it's going to be 422% with an effective rate of 5,000%. Right, and that seems like a lot of interest to be charged. Would anyone say that's a fairly egregious amount of interest to be charged on a loan? Would anyone disagree with that statement? No. So the problem with that is this setup that we're dealing with actually is reflective of payday loans that people take out. So I have a link here under this PowerPoint section. I definitely recommend you take some time to go check this out, right? Payday loan info. All that we're looking at here is it's giving us a range of APRs that are charged on these loans, right? So on the low end, we have 260%. On the high end, we have 1,825% APRs being charged, right? So again, these are APRs. These are the low side, just simple interest statement that you're being told you're going to be charged on these loans. In practice, though, the effective annual rate, as we see scaled up here, is several orders of magnitude larger because of how much compounded interest is occurring within a year. And unfortunately, when you look at the state of Tennessee, it has one of the highest concentrations of payday lending, right? If you just drive around Murfreesboro, you see them pretty frequently around here. Payday loans are absolutely financially disastrous to be taking out. Right? People have a tendency to just see these as a way to get their money a little bit earlier, which technically is true, right? They're giving you those loans a little bit early, but the interest that they're charging you on these loans is extremely high. So in all cases, it's best to avoid taking out these payday loans because you're going to be charged literally an arm and a leg to have to pay these off over time. All right, so I can't state strongly enough how financially disastrous these payday loans can be. Right, so be very careful with where you're getting your sources of capital. They can be really disastrous. Right, people talk about student loans very frequently because so many people take them out. Right, and they can be bad if you're making poor career decisions and taking out hundreds. And I still remember when I was in my associate's degree time period, there was this guy that I knew who somehow was able to get out, like, I want to say he was taking out around $50,000 in loans per year at a community college, and his plan was to become an attorney and just make a stupid amount of money and pay it all back. I don't know what happened to him. I don't think that was happening because, as I remember, he didn't like to do work all that much, and law school is a lot of work. So I don't know what happened to him, and so student loans get a lot of attention because they affect a lot of us, right? I have student loans outstanding that I'm still paying down and will be for a long time. But the interest rate that I'm charged on those loans is between 3 and 7% because they're before the interest rate rise. It's not something that we're dealing with here, which is in a way just literal extortion where you're being charged effectively hundreds and thousands of percent per year. That's just completely financially disastrous. So I can't stress this enough. Payday loans can ruin you financially. Avoid them at all costs. Credit card balances, pay them down every month. Right? That's again something that can sneak up on you and compound extremely quickly. If you just pay your minimum on credit cards, you're being charged interest, and that compounds very quickly, and soon you'll find yourself in a financial hole that is very difficult to climb out of. Right, the earlier you can make smart financial decisions, the better it benefits you. And if you can avoid payday loans, if you can avoid having credit card balances rolling over every month, you're going to be in much better position because you're not paying out most of your income in interest fees themselves. So avoid those. That's the start to making sound financial decisions for yourself. That's the end of my TED Talk. Any questions on interest rates? Okay. All right, so a few of you had some questions. Next week, we're going to keep talking about loans, and we're going to, or not next week, next Tuesday, where are we? Or Tuesday, Thursday of this week. We're going to finish up Unit 2. Again, if you haven't started your homework, you're in a good position to at least get one attempt on homework 2. I'll hang around for a bit to answer any questions you may have. If not, I'll see you on Thursday.